polynomial long division. You'll be able to divide polynomials using long division. Remember that from elementary school? Yeah. So, dividing long division. Some of these are taken from Henrico County, although not a whole lot. First, some simple division. Polynomials divided by a monomial. This is something you did in Algebra 1. First, the easiest thing to do is to separate the polynomial numerator so that you have the 6r squared s plus the 3rs squared minus the 9r squared s, and then put the 3rs underneath each one of it. Then you simplify each term. That is something that you did in Algebra 1. So this is prior knowledge. Doing this, you should get 2rs plus s minus 3r. Remember that 6 divided by 3 is 2. R squared divided by r is r. S squared divided by s is just s. The 3's cancel, leaving you with 1. The r's cancel, still now 1. S squared divided by s is just s. Then you've got your subtraction. 9 divided by 3 is 3. R squared divided by r is r. And the s's make s divided by s makes 1, so it cancels. So now you're left with that 2rs plus s minus 3r. This is Algebra 1. Now, coming down here, try these two. Pause the video and try them. You're back. First, rewrite, then simplify each term. Be careful trying to do it all at once because you're canceling with this term and then you can mess up, just like I did there. You can mess up with the second or the third term. You can confuse yourself. It's easiest to rewrite. For number 3, rewrite and then simplify each term. Remember that 3x divided by 3x, okay, the same thing over the same thing is equal to 1. Not 0. I can't tell you how many people make that mistake and just go, oh, they cancel. There's nothing there. No, they cancel and there is a 1 there. All right, long division. Dividing a polynomial by a polynomial. Ooh, this was long division. This was in elementary school. Can you remember that long ago? Well, trust me, it was longer for me than it was for you. This is the same long division process you learned back then. Step 1, how many times does the divisor go into the dividend? Place that value on top, multiply that value by the divisor, and put the result under the dividend. Subtract, bring down the next number in the dividend, repeat steps 1 through 3 until you have used all the terms in the dividend. And then you either have a remainder or a decimal or something. So we're just going to stop with remainders. Let's take a look at how this works. 17 won't go into just the 3, so I've got to do 17 into 34. That's not really 34, it's 34,000. But I'm just going to, for simplification, block out the hundreds, tens, and ones spot. So 34 divided by 17, that will go in 2 times. In this case, it's really in the thousands place, but 2 times 17 is 34. Now I'm going to subtract. Now I subtract 34,000 from 34,623, and I'm left with 623. The 17 won't go into the 0, so I have to put a 0 here to hold the place value. Now I can look at 17 going to 620. How many times will 17 go into 620? Well, 6 times? No, obviously it's not going to be 6 times. Yes, you are going to have some kind of number sense. Okay, so 62 divided by 17. 17 is almost 20, so I would say it would be 3, possibly 4, but probably 3. 3 times 7 is 21. Carry your 2. 3 times 1 is 3 plus 2. Okay, it's 5. Now we have the 3 comes down. 62 minus 51 is 93. 93 divided by 17. Oh, and by the way, I had to subtract that. Is, oh, let me move the little recording thing so that I have some more room and extend my page. Okay. Oops. 0 there. Now, 17 won't go into 9, so that was good. I can't do 4. But 17 will go into 93 5 times evenly. So 5, then times the 17 will give me 85. Then I subtract again. 93 minus 85 is 8. That means I have a remainder of 8, or 8/17. So I can write this as 2034 and 8/17, or sorry, 34, 35, 2035, remainder 8. Either one. There are times where we want to just look at the remainder, and there are times where we want to write it as a fraction. This is the process that you should have learned in elementary school. Moving on. What happens when it's a polynomial? Well, I'm going to walk through it here with you. If you're given x squared minus 5x minus 24 divided by x plus 3, first, write it long division. Then, you're going to take and you're going to look at the x and this very first term, x squared. How many times will x go into x squared? X times. Then I'm going to multiply x times x plus 3, and oops, I get x squared minus 3x. Now, the next step is to subtract this x squared plus 3x. So I do the subtraction. Remember that I have to distribute that negative. So now I've got negative 8x minus 24. How many times will x go into negative 8x? Hopefully you said negative 8 times. Now negative 8 times x plus 3 gives me negative 8x minus 24. What do I have to do? I have to subtract. When I subtract, I get 0. That means my remainder is 0. So that also tells me that x plus 3 is a factor. So that means that this up here is equal to x minus 8. Another way to look at that is if you factored x squared minus 5x minus 24, what would you get? Ooh, x plus 3 and x minus 8. See? All coming together, connections. Okay? Now, you get to try one. But here's a tricky thing. If a term is missing, coefficient is 0, that must be included when you rewrite. Remember that 503 is not the same as 53, but can be written in just two terms as 5 times 10 squared plus 3. Okay? So, for this one, I don't have an h squared. So I put in 0h squared. Now, I'm going to start it with you. H goes into h cubed, h squared times. H squared times h is h cubed. H squared times negative 4 is minus 4h squared. Now I have to subtract, which means essentially I change all of the signs. This should cancel. 0 plus 4h squared is 4h squared. Bring down the rest of the polynomial. Be careful when you're bringing down the rest of the polynomial, you bring it down correctly. Now, h will go into 4h squared 4h times. 4h times h is 4h squared. 4h times negative 4 is minus 16h. And there's nothing else there. Now I'm going to subtract, which means I'm changing all the signs. This first term should eliminate. Now I've got negative 11 plus 16 is 5h, and I bring down the 28. H will go into 5h 5 times, multiply 5 times h, I get 5h. 5 times negative 4, I get minus 20. I have to subtract. And this is where having the second color pen or pencil comes in handy. You can see that you've subtracted. 28 plus 20 is 48. I don't know how many times h will go into 48. So that means I have remainder 48. I could also write my quotient as h squared plus 4h plus 5 plus 48 over h minus 4. As soon as you tell me what h is, I could finish this up, right? Good. Okay, notice if there is a remainder, place it over the divisor and add to the quotient. Right, next one up. Here are these three. Try these on your own, put it in standard form, and then rewrite it. Okay, did you go away? Did you do everything you were supposed to? You did? Are you sure? Okay, just checking, giving you that option. Here, we have to rewrite it. Now notice in this case, everything's good, just had to rewrite. So, 5x goes into 10x cubed, 2x squared times 2 times 5 is 10, get x cubed. 2x squared minus 2 is minus 4x squared. Do my subtraction. Remember, subtracting means changing all the signs. Eliminated. 1 plus 4 is 5x squared plus 3x plus 7. 5x will go into 5x squared x times 5x. 5x squared, x times negative 2 is minus 2x. Subtract, and you're going to get 5x plus 7. 5x will go into 5x once. Let me see if I can do this. Put this over here. So now I've got 5x minus 2. I have to subtract. This one did not go evenly. So I've got 7 plus 2 is 9. This becomes plus 9, 5x minus 2. The remainder is 9. Again, sometimes you just want to know the remainder. Other times you want it written out as a whole quotient. Okay, now I'm going to take all of this and move it here, which I'll come back to after I do these. First, I want to put it in standard form, because notice I have a 2x to the 4th and a 7x cubed. Those should move up front. The 3x squared should come up front. 6x and the minus 2 goes to the back. X squared comes up front. Okay, this looks ugly and awful, but it's okay. It's not bad. Now, I rewrite it like this. And remember, I'm focusing just on my x squared. X squared will go into 2x to the 4th, 2x squared times. 2x squared times x squared is 2x to the 4th. 2x squared times 2x is 4x cubed. 2x squared times 1 is plus 2x squared. Subtract. And now I've got 2x to the 4th minus 2x to the 4th. I've got 7 minus 4, 3x cubed. Negative 3 minus 2 minus 5x squared. Plus 6x minus 2, just bringing it down. Now, again, I'm looking at the x squared and the 3x cubed. Well, that will go in 3x times. 3x times x squared is 3x cubed. 3x times 2x is 6x squared. 3x times 1 is 3x. Remember to subtract. Then add each one. This pair is 0, negative 5, negative 6. I have negative 11x squared. 6 minus 3 leaves me still with a 3x. And then I've got my minus 2. How many times will x squared go into negative 11? Well, negative 11x squared, negative 11 times. And multiply negative 11 times x squared, negative 11x squared, negative 11 times 2x is minus 22x. Negative 11 times 1 is minus 11. Now I have to go through and subtract, which basically means changing all my signs. I've got a 0 pair. 3 plus 22 is 25x, and this is plus 9. This becomes plus 25x plus 9 all over x squared plus 2x plus 1. This is my remainder. Okay? I can't do x squared into x. This last one, hopefully you rewrote all the missing terms. You needed an x squared and an x. Notice that this is a difference of cubes. This is addition, not subtraction. Don't forget SOAP. This had been SOAP. Could have done it by factoring, but it's not. So, without further ado, x will go into x cubed, x squared times. We get x cubed, whoops, plus 3x squared. We subtract. Give myself some extra room. We subtract, and now we've got negative 3x squared plus 0x minus 27. This will go in minus 3x times negative 3x squared minus 9x. Gotta subtract. 0 pair, 9x minus 27. X will go into 9x 9 times. So I get 9x plus 27. Be ever so careful here. I subtract. And then notice that goes away, but negative 27 minus 27, negative 54. So now I have plus negative 54 over x plus 3. It's very, very tempting to say that there's no remainder there if you're going too quickly. Summary. Long polynomial division follows the same procedure learned in 3rd, maybe 4th grade for performing long division on numbers. How many times is the divisor going to the dividend? Place that value on top, multiply, subtract, then keep going. Rinse and repeat. Okay? You've got some practice. Tomorrow I'll show you a shortcut for certain problems. Not all problems, just some of them.